In this chapter, we would focus on physical and chemical changes and start our lecture with what are various types of 5 different classification for understanding the changes. Under types of changes, we would understand 5 classifications. The first is based on time interval. That means those things which occur at a fixed time interval, it is periodic. For example, you sleep every night, you wake up every morning, you eat food every day morning and evening. So cooking morning and evening probably would be a periodic event. Then we can say seasons is again a periodic event. You go to school, you return from school, periodic event. Every class of 40 minutes, periodic event. What are non-periodic events? Non-periodic events do not happen at a fixed interval. So for example, we went for an outing on a chariot. Now every day or every week this does not happen. It was sometime we went and probably sometime later in life we would go again. On the same way, when we are on the road, there could be instances that there is huge traffic. So a lot of brakes are required while on the road. In other circumstances, the road is smooth, so the braking is less frequent. So again, it is not periodic. Similarly, a moving watch is an example of a periodic event. However, I can have an example of this watch here. It has stopped working. So it is non-periodic. It does not happen at fixed interval of time. Now, the next classification that we understand is based on speed. Based on speed, it can be slow or a fast change. For example, a child grows from a little baby to an adult and then to an old age person. Or we can have another example, our evolution from primates. So, human beings evolved. Again, a slow change. Another good example we have here are 2 plums. So, one of those you can see is a little red. The other one is dark maroon. So, this is an example of a slow change, ripening of the fruits. The next example is a fast example. I have a matchbox here and definitely now you understand. So what I do is I light a matchstick and this is an example of a fast change. So we understand slow change and fast change. Coming back next, what is important is the changes which are either reversible or non-reversible. Reversible change, simply I can say I take a ice, I bring it outside the fridge and it melts. I take that melted water again and keep it inside the fridge. It again converts into ice. Very simple example. What is non-reversible? A knife here, a pear here. I just have a slice and probably I am hungry, so I would like to eat it. So this is a non-reversible change. I cannot join this piece back onto the pear. The next important thing that we understand here is another classification which can be based on reversible and non-reversible change, and that can be explained by this simple sheet of paper. How? I take this paper, I fold it. What is this? This is a reversible change. I can unfold it anytime. Now, same piece of paper. What I do is, I take the paper, I tear it. Can I join it without a tape? No. So this is not reversible. So with the same example of paper, we have understood that folding of the paper is a reversible change. However, if I tear a paper, it is non-reversible change. Don't go. We have another interesting example with the same paper. The next is a physical change and a chemical change. So the same paper, folding of this paper, tearing of this paper is definitely a physical change. But folding was a physical reversible change. However, tearing of the paper was a physical non-reversible change. So never go by the words that physical changes are reversible. Physical changes can be reversible, can be non-reversible. Then I have an example with the chemical change. Chemical change, process of digestion, process of respiration, process of photosynthesis, fireworks, or let me take another example I have here, and what I do is I simply take a matchstick. I light the matchstick and I put this paper on fire. So what would happen? This is an example of burning of the paper. So chemical change. So with this paper we have seen all kinds of changes, but this is a chemical non-reversible change. Clear? This burnt paper cannot come back. So this is a chemical non-reversible change. But again in chemical change, we do have reversible changes. What can be an example of a chemical change which is reversible? The change is very simple. Hydrogen plus iodine would give me hydrogen iodide, and when I do a reverse of it, this hydrogen iodide would again lead to hydrogen and iodine. So this is a reversible change. So coming back to a quick summary. Never go by the words that physical changes are reversible, chemical changes are non-reversible. A simple example that we would cite for all the four again. Physical reversible change, I can say folding of the paper. Physical non-reversible change is tearing of the paper. Chemical non-reversible change is burning of the paper. And an example of chemical reversible change is hydrogen plus iodine, which gives us hydrogen iodide, and this hydrogen iodide can further disintegrate into hydrogen and iodine. So we have physical and chemical changes which can be reversible as well as non-reversible. Very important, very logical. Types of change based on energy. So based on energy, it can be exothermic or endothermic in nature. As the name suggests, exo means release. So the heat is released. However, endo means in. So the heat is absorbed. And this is the basic difference between an endothermic and an exothermic reaction. Now, to simply understand the process, let's say we have the three states of matter: gas to liquid and liquid to solid. Now, from gas to liquid, this process would be condensation, and from liquid to solid, the process would be freezing. Both of them would release heat. However, converting from solid to liquid and liquid to gas, from solid to liquid it would be melting, and from liquid to gas it would be evaporation. Both of these would require heat, and therefore these are endothermic in nature. However, condensation and freezing would be exothermic in nature. So when I say endothermic, I can say melting of water, melting of snow are endothermic reactions. However, when I say exothermic, formation of snow is a exothermic example. Okay, similarly, if I am burning something, burning of a candle, burning of a wood, or simply I have a matchstick again for you this time and I burn it, so heat is released, and therefore this is an example of the exothermic basis. Now, a quick recap of what we have done, the various types of changes and the classification. So we understood 5 different classifications. The first was very simple: events that occur at regular interval, going to school, attending the classes, having 40 minutes classes. So that's a periodic event. Non-periodic event is once in a while, going for an outing, going probably this season and 4 months later or 2 years later. So it's a non-periodic event. Changes which can be slow and fast. Evolution of human beings from primates is a slow change. Burning of a candle is a fast change. Changes can be physical or chemical. If I tear a paper, it is a physical change. If I burn a paper, it is a chemical change. Reversible or non-reversible. So tearing of a paper again is non-reversible. Folding of a paper is reversible change. And then endothermic and exothermic. Endothermic where heat is absorbed, however exothermic where heat is released. We understood the examples for all of this. So this is about the various types of changes. Physical changes. Now physical changes are those changes in which the physical property changes, the chemical property remains unaltered. That means I can witness a change in shape, a change in size, a change in color, and usually no new substance is formed. So there can be changes in the state of matter, there can be separation of mixtures, there can be physical deformations. If I have this paper and if I have this paper in hand and I crush this paper, so there is a deformation, but I can again make this paper normal. So this is an example of a physical change. Only energy is added or removed and mass is not involved in a physical change. This physical change can be as crystallization, as sublimation. We would understand that in a while. So let's move with the various examples of physical change. So coming to the examples of physical change, I have a scale here. I bend this scale and this scale regains its shape. So there is a change in shape and this shape turns back. What it is? Definitely a physical change. I have another example. A paper here. I fold this paper. This is a physical change, but again it is a reversible change because I can unfold this paper again. The next is I take this paper, I already have teared one, I tear another piece of it. This is again a physical change. There is no change in the chemical property, but yes, this is a non-reversible change because I cannot join this paper again without a sellotape. Okay, let's move to another example. I have a pear. Already I have taken one slice. So let me take another slice. And this is an example of a physical change. Cutting through knife is a physical change. Another examples of physical change I can say is a candle here. I light this candle. Now visualize carefully what I am trying to explain here. First, we will talk with respect to candle itself. With respect to candle, when this candle is blowing. Now, when this candle is blowing, it is burning the wax. Now, this burning of the wax which is seen is a chemical change. Note. But the wax which is melting here is a physical change. This melted wax can again be collected and formed as another candle. So, melting of the wax would be a physical change, but the burning would be a chemical change. That was one thing. Now, what I do, I missed something. Okay, so here I have a piece of blade, not a piece of blade, a blade itself. Okay, so what I do is, I take out this blade and I have a tong here. I just put this in the tong and I heat it. I heat it till the time it becomes red. So probably you can see the corner has gone a little blackish as you can visualize here. So the color has changed. Now when it dries or when it becomes cold, I can just remove the soot and the color again becomes normal. So there was a change in color and this is a physical change. So with this blade we did one example which is an example of a physical change. Again, I take this pencil and a sharpener. So, let's have some fun time. I am sharpening this pencil and this is an example of physical change. No chemical change occurred here. Simply, the rolls have come out. Again, another example. Okay, so I have a bottle of sanitizer here. Now, this sanitizer, I take some of it into hand and rub it. So, it goes off and it is basically volatile. So, what happens is, this is an example of a physical change. So, we have understood some of the examples for physical change. Let's proceed further. So, let's talk about some further examples. I have not brought it because by the time I would have brought it, it would have melted. But the idea is I take snow or I take ice and melt it. So this is a physical change, that melted ice can again be reformed into ice back and therefore is an example of physical change. Water cycle, formation of clouds, rain occurring, evaporation taking place, all of those is an example of what? Physical change. So the whole of the hydrological cycle which we see is an example of a physical change. Definitely I cannot bring it here, so you might not worry about it. The next is physical change due to hydration. Now this is where we have an interesting example of cobalt chloride. Now cobalt chloride is a very fascinating example. I have certain cobalt chloride with me and this is pink in color. It responds very well with the humidity. So it is also known as humidity indicator. What I do is this pink colored beautiful cobalt chloride, I start to heat it. Now as soon as I heat it, what would happen? It changes to blue. Now what would happen again? I leave it for a while, it would start to absorb moisture and again turn pink. And this is a physical change. And this physical change is due to hydration. So when we take cobalt chloride, it is pink in color. When we heat it, it becomes blue in color. Then left again, it absorbs moisture, becomes pink in color. And this is a physical change due to hydration, a beautiful example to understand the changes of color. The next is physical change due to crystallization. So for this, we take certain water in a beaker and add few drops of copper sulphate into it, and with the copper sulphate, we also put some kind of salt crystals or sulphuric acid and start to boil it. Now, this copper sulphate solution over the time would form copper sulphate crystals, and that is how we basically understand this process. So here we have a copper sulphate solution. What I do is, copper sulphate with me, what I do is I take a little of this copper sulphate and put it in a beaker. Now probably I don't know whether this would turn into successful experiment for now or not, but yes, this copper sulphate is there in this solution, and what is next is to understand that this copper sulphate solution, if I heat it, what would happen? When I heat it, this copper sulphate solution the copper sulphate would crystallize again, and this is a physical change which occurs, and this is due to crystallization. The next important example that we understood was due to sublimation. So dry ice, in which you usually have your ice creams which are kept by ice cream vendors, is a very good example of physical change. So that dry ice basically converts directly from a solid form and it gets dispersed, it disappears, that is, it changes into gas. So changing from a solid form to a gaseous form, for example, dry ice, that is the frozen form of carbon dioxide, is an example of sublimation. Another good example of sublimation is camphor. So again changes from solid form into a gaseous form. So these are some of the ways through which we understand physical changes. In this section, we have understood the various changes that are physical in nature. Understanding chemical changes. So in chemical changes, there is a change in the chemical property. So burning of paper, burning of wood, burning of candle, burning of paper, all of those are good examples of changes in the chemical composition. So there can be production of heat, there can be production of light or any other radiation, ultraviolet radiation or even sound. All of those would be an example of chemical change. So very good example is to start with fireworks. Now this fireworks have great sounds and this is an example of a chemical change. So sound is produced here. The next is an example of photosynthesis. Photosynthesis, the process of digestion, the process of respiration, or when I am cooking food, mixing various ingredients, so the chemical composition changes, new substances form, and this is an example of a chemical change. So there can be formation of heat, formation of light, or formation of gas in a case of a chemical changes. Also, a very good example is a battery or burning. So what I do again is I have certain simple demonstrations. I take a paper, I tear this paper. This is a physical change, not a chemical change. Now what I do is I simply light the candle. Now when I am lighting this candle, just a second. So what I do is I light this candle, and lightning of this candle itself has both kind of changes. So it is a physical change as well as a chemical change. How? The physical change here would be melting of the wax, as we know and we have discussed in the physical change. However, this burning is a instance where chemical changes takes place and therefore is an example of chemical change. Now, I take this paper, I take this tongue, I hold this paper and I start to burn. So when I burn this paper, this is an example of a chemical change. Another good example we take is, this is a magnesium ribbon. I take a little section of this ribbon, easy to break. Note, it is very dangerous, so don't observe this directly when you are in laboratory with your eyes. So just take a note. If you have this practical going on somewhere near to you, don't observe the flames directly. It has a white flame. And when you burn this magnesium ribbon, what would happen? This magnesium would turn into a powdery substance which is white in color. Now, this is how magnesium oxide is formed. You can visualize it through the video but not directly. So that is an instruction specifically given for you. Now when you are burning this, magnesium oxide is produced, and this magnesium oxide, which is white in color, would then be taken into a solution of phenolphthalein. What is phenolphthalein? Phenolphthalein is a bottle that you can see here. So this is what phenolphthalein is. It is an indicator for understanding the presence of acid or base. Now this magnesium is basic in nature. So what I do is, if I pour this magnesium into this phenolphthalein solution, it required more heat before it could turn white. Anyways, but when we put it into the phenolphthalein, it would start to turn pink, as you can see here. So there is a change in the color for this rod. If you can visualize from below, this changes into pink, and this indicates this is a base. So phenolphthalein is an indicator which turns pink on basic solution. However, it remains colorless for acidic solution. So since magnesium hydroxide is a weak base, it would reflect pink color. We would understand this in a while again. So that is a basic experiment to understand the presence of chemical changes. So as we said, here the experiment runs. So we have magnesium. When this magnesium combines with oxygen of the air, it forms magnesium oxide, and as we said, don't visualize it directly. It burns with a brilliant white light, and therefore it forms the magnesium oxide, which is a chemical change. Now this magnesium oxide, when I react this with water, it forms magnesium hydroxide. Magnesium hydroxide is a basic solution, and this would turn pink in presence of phenolphthalein. Phenolphthalein is a indicator for acid base. Again I repeat, it would turn pink for base, but phenolphthalein would remain colorless solution for the acids. Okay, so this is how we understand the solution. And now we have a beautiful color. If you can visualize, let me zoom it again. So Probably you can have a closer look now how the solution turns pink. Let me pull it out, and you can see this turning into a pink solution. Probably it's not visible as a pink now. I put a hand here and you can see a little pinkish shade. I'll show you after a little while again how this changes into a pink color. Okay, let me leave it for another few minutes and we would see it again. Okay, so this is how we have the magnesium hydroxide formation and reaction with phenolphthalein. The next is rusting of iron. So rusting of iron, we have iron, and this in presence of water or oxygen would form iron oxide, and this iron oxide is the rusting that you can see here. So this is an important example to understand a chemical change. How can we avoid this rusting? There are various ways. Galvanization is one of the way. Cathodic protections are another way, and stainless steel, of course, which we use for our cooking purpose. Now, galvanization is where we are treating a layer of zinc on iron, and this zinc on iron protects the rusting. Then we have the cathodic protection. Cathodic protection, what happens? We connect an external anode to the metal, and this external anode to the metal would have the current flow, and this would finally create a layer which would avoid rusting. Similarly, stainless steel, we have iron mixed with chromium, nickel, manganese, and all these help to reinforce it and prevent it from rusting. But we have a classic example of Qutub Minar. Qutub Minar in Delhi has an iron pillar. Now this iron pillar is more than 7 meters high. It has a weight of more than 6,000 kilograms, and it has not rusted for a very long period of time, and therefore has created an enthusiasm among scholars to understand how this iron was created, so that it has not rusted till date. So rusting of iron, a very clear example of chemical change. Let's go back to that magnesium hydroxide, and now I won't disturb this and just pull it closer to the camera. So probably you can see the pink color visualization better now, and this is how we understand that magnesium oxide, when combines with water, forms a magnesium hydroxide, and this, when we have few drops of kind of pieces of phenolphthalein that we add, it changes into a brilliant pink color, indicating that it is a base. So acid base we would understand further later in our separate lecture. Coming on back to another examples of rusting. So another example is copper solution. Now copper solution, and we have iron, a very good example. So we have certain copper solution here, and I put this copper solution into this flask. So I had kept it a little while ago, and I was waiting for this iron nail to rust or to turn brown, but it has not happened as of now. But this solution would basically turn greenish, and this iron nail would turn brown. So this is how the copper sulphate reacts. Now to put it in a simple equation, what we have is iron, which is the form of nail that we introduced here, would react with this copper sulphate solution, and then we would have formation of copper and iron sulphate. This iron sulphate, this water would turn from pink to little greenish over time, and this is how we have the iron sulphate, which turns greenish in color. However, on the other hand, we have copper that turns what? This copper would turn brown in color. Okay, so copper turning brown and iron sulphate turning green. So another good example of a chemical change. Now coming on to another simple example, this is vinegar and baking soda. I didn't have the vinegar to have this live experiment here, but yes, the idea is we combine vinegar and baking soda. Now when these are combined, what would happen? Carbon dioxide would be released. Now what is baking soda? Just for your knowledge, it is sodium hydrogen carbonate. So sodium hydrogen carbonate, which is baking soda, combines with vinegar, which is acetic acid, and this acetic acid and baking soda would release carbon dioxide and other substance. Let's leave the other substance, focus on carbon dioxide for now. So what I do is I obtain this carbon dioxide and put it in the lime water. Now as soon as lime water has this carbon dioxide, this lime water would turn milky, and this is due to a very simple reaction. What is that? Carbon dioxide combines with lime water, CaOH whole twice, which gives you CaCO3, which is calcium carbonate and water. And this calcium carbonate is responsible for turning the solution milky in color. So when this carbon dioxide passes through the lime water turns milky due to formation of calcium carbonate, and this is a standard test also for understanding the presence of carbon dioxide, that lime water turns milky, and also an example of a chemical change. So that was a very basic example to understand the chemical change. So understanding a quick difference between what is a physical change versus a chemical change. So in the physical change, the molecules are reorganized, rearranged, but the real composition remains the same. However, in a chemical change, there is a change in an electronic configuration, the change in the atoms, and new substances are produced, and therefore they are called as a chemical change. A very important thing to note here is both the physical and the chemical changes can be reversible or non-reversible. We cannot say that physical changes are reversible and chemical changes are non-reversible. That is incorrect. I can have a simple example for you. For the physical change which is reversible, I have the folding of the paper. But for the same physical change, I have tearing of the paper, which is non-reversible. So we did reversible and non-reversible for physical change. One is folding of the paper, the other is tearing of the paper. The same goes with chemical reaction. It can be reversible, it can be non-reversible. If I take this piece of paper and I burn it, this would be a non-reversible chemical change because it is burning, new substances are produced. However, a reversible example of a chemical change would be reaction of hydrogen and iodine to form hydrogen iodide, and then hydrogen iodide disintegrating again into hydrogen and iodide separately. So that is a chemical reversible change. So very important to note, both physical and chemical changes can be reversible and irreversible in nature, but in physical change, there is a change in physical form only. There can be change in shape, size, color. However, in a chemical change, there is a change in the chemical form, but at the same time, there can be change in the physical form also. For example, when I take this paper and I burn it, so there would be a little piece of it which would be burnt. So this would create a change in the physical form of the paper. It was previously like this, now a little section gone which was burnt, and therefore there is a change in the physical form as well. So when there is a chemical reaction, chemical change, there can be a change in the physical form as well along with the chemical change. The chemical form which changes. However, in a physical change, there is exclusively the change in the physical form. So, those are the only two major differences which we can understand for the physical changes and the chemical changes. So, this was about our lecture on physical and chemical changes. We would be covering many such interesting lectures in chemistry and science. Stay subscribed. Have a wonderful day ahead.